Hello friends, myself R.D. Mahajan presenting my one more video on beta and gamma function. Evaluate integral from 0 to 1 x cube multiplied by 1 minus root x whole raised to 5 and its integration with respect to x, and to evaluate the value as the limits are 0 to 1 and it is somewhat similar to form of beta function. We know that beta of mn as integral from 0 to 1 x to m minus 1 1 minus x to n minus 1 and its integration with respect to x. Therefore, to obtain this form we have to substitute root x as t, but before that we consider let I is equals to integral from 0 to 1 x cube 1 minus root x raised to 5 and its integration with respect to x as equation 1. And then in this integral we substitute root x as some t, a new variable. Squaring both sides we get x is equal to t square. Differentiating it with respect to x we get dx is equals to 2t dt. And as we are using the new substitution, we try to find out the new limits. For x is equal to 0, we get, if we put x is equal to 0 here, we get t as 0. And for x is equals to 1, we get t is equals to root of 1. Root 1 is 1. And then substituting this information in equation 1 becomes I is equal to, limits remain same, 0 to 1. Here x is t square and it raised to 3. 1 minus root x, 1 minus t, and that raised to 5, and dx is 2t dt. To constant we take outside the integral sign, therefore it is 2 times integral from 0 to 1 t raised to 6 and one more t, it becomes t raised to 7 and 1 minus t raised to 5 dt. We try to rewrite in the form of a definition of beta function by adding 1 and subtracting 1. Therefore, in next step I can rewrite this as 2 times integral from 0 to 1. This t raised to 7 we can write as 8 minus 1. 7 plus 1 minus 1. 7 plus 1 we get 8 and minus 1. And 1 minus t raised to 5 we can write down as 6 minus 1. So that we get this form and its integration with respect to t. And then it is 2 times x to m minus 1. 1 minus x to n minus 1 is nothing but beta of mn, m8, n6. And then applying that relation, we know that beta of mn is equals to gamma n divided by gamma m plus n. Using this relation between beta and gamma, and therefore it is equals to 2 times gamma of 8, that 8 gamma of 6 and divided by gamma of 8 plus 6, it is 14. It is equals to 2 times, to evaluate the value of gamma, I will rewrite that 8 as 7 plus 1 in the form of m plus 1 or gamma n plus 1, therefore it is 7 plus 1. Gamma of 6 as 5 plus 1 divided by gamma of 14 as 13 plus 1, and that is equals to we use the property gamma of n plus 1 is n factorial if n is positive integer. Using this property, and therefore we get the value as 2 times 7 plus 1. Gamma 7 plus 1 is nothing but 7 factorial. Gamma 5 plus 1 is 5 factorial. Divided by 13 factorial. Okay, and therefore we get the value as 2 as it is, no change. 7 factorial I will keep as it is. 5 factorial is 120. Divided by 13 factorial. 13 factorial I can rewrite as 13 into 12 into 11 into 10 into 9 into 8 and into 7 factorial. So that this 7 factorial will cancel. 12 into 10, 120, cancel with 120, and then dividing by 2 we get here 6. Therefore that value is 1 upon that product of 13 into 13 into 11 into 9 and into 4. That product is 5148. 5148. As the answer for this definite integral. One upon 5148. Once again I will simplify this. 120 cancel with this 120. 7 factorial cancel with 7 factorial. Dividing by 2 we get here 4. Therefore 13 into 11 into 9 into 4, that product if you perform by calculator it is coming as 5148. Therefore the value is 1 upon 5148. Important one is we have to convert the integral in this beta form by using this substitution, then obtaining the new limits, thereby getting the beta form, and then using this relation between beta gamma we convert in terms of gamma, so that we get the value of gamma n plus 1 as n factorial, as it is a positive integer in all the cases. 7 is positive integer, 5 is also positive integer, and 13 is also positive integer. And then simplifying it, we get that value as 1 upon 5148. One more I will discuss in my next video. If you like my videos, please share it as well as subscribe to my channel to get notification for my new videos. For that you have to press the bell icon. Thank you very much.